Hi everyone, welcome back to Made Easy Academia. So this morning our today discussion will be based on sequence and series as well, AP and GP, how we can make use of some questions, even together with the one that we have as sum to infinity concerning the GP. So please follow us, subscribe to our channel so that you can have more updates from our website. Thanks. Now, based on sequence and series, we talk about the AP and as well the GP. So this area is very interesting and you find it more fun that you see some problems, maybe some Java questions or concerning Y Koneko. So in this area, we discussed about a lot of problems here. So when we are talking about the sequence, what do you mean by sequence? Sequence is just like the arrangement of numbers in a particular order governed by the same rule. Like for example, let's say we have we're talking about the sequence. So when we have arrangement of numbers in a particular order governed by the same rule is what we call sequence. For example, if I have 2, 4, 6, 8, 10 like that, you can see these numbers, they govern by the same what? By the same rule. Or if you have like let's say we have 1 cube or 2 cube or 3 cube or we have 4 cube like that, you can see in these numbers they govern by the same rule. It might be alphabet, it's the same thing. So when they govern by the same rule, we call it a sequence. So the addition of this sequence is what we call series. Addition of the sequence. Series is just like addition of the sequence. When we have, let me take a look. For example, let's take the first one. For example, when we have 2, 4, 6, you can see clearly this one is a sequence, right? So by adding these terms together, by adding all these numbers together, is what we call series. So you can say the series is just like the addition of what? Addition of a sequence. Like these are 2 plus 4 plus 6 plus 8 plus 10 like that. So you can revert to our material we are using for this particular sequence and series to have more examples so that you can be able to learn a lot about it. But in literally meaning, when we have a number, when we have arrangement of the numbers in a particular order governed by the same rule, we call it a sequence. So the addition of all those terms, addition of the sequence is what we call series. So we have different type of sequence in maths. We have arithmetic sequence, they are mainly like that. We have geometric sequence. So one of the one we are going to talk about, we call it arithmetic progression. Call it before we talk about, let's first talk about arithmetic progression. AP arithmetic, to save our time, let's just short it. Arithmetic progression, so we call it a linear sequence. Call it linear sequence. So to save our time, no, you have to take note of something here. In some cases, they can call it arithmetic progressions, like they can use it in full like this, arithmetic progression, or they can call it a linear sequence. Either they call it as a linear sequence or they call it arithmetic progression. The two are the same, so don't be confused. No, maths too, we love making things more easier, or just like the way we have synonyms in English language. So either they call it linear sequence or they call it arithmetic progression. The two are still the same. Now, how can we identify or how can we differentiate between when we have arithmetic progression, or what do we mean by arithmetic progression itself? It's like when we have a term that have the same difference, like integer. Let's say we have let's take a look at for example, when we have a term like 2, well, let me take a look at this. Let's say we have 5, 10, 15, 20, 25. Let's say we have something like this. If you look at it, you can see this is the first time that we have here. If you look at all these numbers, do they have the same difference? That's the first thing we are going to check. If they have the same difference, then we can call it arithmetic what? Progressions. For example, if you look at the first, let's call them time by time. Let's say this is the first term, this is the second term, let's say this is the third term. Note this one I'm using here is just like a term. Familiar yourself with that one before. So this is like a fourth term. Let's say this one is just like a fifth term. Now, if you look at this sequence, let's check if they have the same difference. Now, if I look at it, so if I have the second term and the first term, do they have the same difference? So let's check. That's our second term minus first term, meaning that is a 10 minus 5. You can see 10 minus 5, of course, we are going to have 5, isn't it? Or let's say we have the third term minus the second term. So if I have third term minus second term here, that is the third term we have is a 15 minus 10, of course, we are going to have 5. Or let's say we take by fourth term minus third term, that is a 20 minus 15. So we are going to have, so far, if it is arithmetic progressions, we are expected to have the same difference. So even if the terms is in form of alphabet, it can be in form of alphabet. Maybe the first one is X. Once you know the government, once you know the law that govern them, just find the difference. So far, if this AP or linear sequence, we are expecting the terms to have the same difference. Now, let's take a look at general terms of an AP. So please go back to if you check our material, you will see the derivation of how we derive the general terms to find an AP to make your work easier if you get any confused. So now, general terms of an AP. So I will explain what each letter is represented so that you don't get confused. And how you can make use of the formulas, how you can apply them. So the general terms of an AP is general terms of an AP. General terms of an AP. So the general term of an AP is always given as this. I will explain each of them. Tn is equal to A plus n minus 1d. So please, if you check our materials, you see how we derive these formulas, how we make it to be this. So to save our time and to make it more easier, to make it more interesting, that's how we base our argument on this. So let's explain what each alphabet here represented. Now, Tn, you see the Tn is simply means the nth term. So please take note of that. Whenever you get the word Tn, even if someone in some textbook, instead of using Tn, they can use Un. It's still the same thing. Either they use this or they use this, they are still referring to the same thing. So now, when we have A here, it simply means the first term, the first given term in the sequence. Let's say we have, I will explain them. So if you have n simply means the number of term, the term that we are referring to, either 7th term, either 10th term, or either 15th term. Now, the D that we have here, it simply means the common difference. That is the difference. You know, I told you earlier that for a term to be arithmetic progression, we are expecting the term to have the same difference. But if you check, I will discover that the term doesn't have the same difference, then the term is not a linear It's not a linear progressions. How? So let's explain how we can make. Let's say, for example, let's say I have something like this: 2, 4, 6, 8, 10. Let's assume that I have a sequence like this. If I have a sequence like this, let's say that I want to make use of this approach. Let's say I want to make use of this approach. For example, let's say we have 2, 4, 6, 8, and 10, and I want to explain how I can make use of all these data that we have here. How can we explain the nth term? How can we explain the fourth term? How can we explain the number of terms? How can we explain the common difference? You know, I told you, when a term have the same difference is called, you can see from that word, the same difference. That is a common word, the common difference. For example, I have 2, 4, 6, 8, 10. So I want to explain all this one after the other. So if I label them, this is going to be my first term. This is going to be my the last term, or the second term rather. This is going to be my third term. Here is going to be my fourth term, and this is going to be my fifth term. Just like the last term here, isn't it? So each term sometimes we do to make it easier. They do interpret just like the last term. Now, so if I want to identify the A here, you know, we said A simply means the fourth term. So the fourth term here that we are going to have here is going to be 2, because this is the first term here. I hope you are following. So the first given numbers is what we call the first term. So instead of writing it in words, they use an alphabet called E. So whenever we see A simply means the first term. I hope we are following, right? Yeah, good. So when we have D, you know, from that one we say D simply means the common difference. So what do you mean by common difference? The common difference simply means the difference between each terms. the difference either between the first term and the second term, or between the third term and the second term, or between the fourth and the fifth. Anyhow, no matter how the group, you can find your common difference as far as that sequence satisfies the condition of an AP. A term is said to be an AP if they have the same difference. You can find a difference anywhere of the sequence. So far it is an AP, it will satisfy the conditions. How? Let's look at this. So if I want to find the common difference here, I can say second term minus first term, or I can call it a third term minus second term, or I can even use fourth term minus third term, because what I'm expecting here is that they satisfy the condition of an AP. So if they satisfy the condition of an AP, then we can say that sequence is said to be an AP. So let's see if they have the same difference here. If I check, what is the second term here? Let's check. The second term here is what? Yeah, it's 4 exactly. That is a 4 minus. So what is the first term here? Yeah, 2. So 4 minus 2 here, of course, we are going to have 2. So which means if I check for third term minus second term, if they must have the same difference as what? As 2. So let's check. You can say the difference is equal to third term minus second term. So the third term here we have here is 6 minus the second term we have here is 4. So 6 minus 4, of course, we are going to have 2. Or let's check the other one so that for us to satisfy if our condition is right or wrong. So if I take this, I have fourth term minus third term. So if you check here, what's our fourth term here? Yeah, exactly. That is our 8. And the third time we have here is 6. That is our 8 minus 6. Of course, we are going to have 2. So you can see when we check it by first term by the second term, or we check third term by the second term, or we check fourth term by the third term, we can see that they all have the same difference. So that's what we call the common. That's what they call it, a common difference. So note one thing here: your common difference can be negative. So it's not as if maybe it's always positive. It depends on how you have the sequence. So there's some sequence, maybe the first term will be bigger than the first term. It doesn't matter. Just following the same process. We are going to solve many examples. Many examples, either the term will be negative, even we have some problems that the common difference will not be given. That's why we have made this academia here to solve your problem. No matter how the problem comes, either in a big one, just follow the same process. So we are here to help you guys. So inshallah, we are going to discuss a lot of the problems here. Now, let's explain the number of terms here. We said n simply means the number of terms. What is the number of terms? Means the number of the terms. When we count the terms, how many times do we have there? So like for example, since we are just giving an example here, if I want to determine the number of terms of this sequence, if you count it, it is the first term, second, third, fourth, and fifth. Meaning here, the number of terms here is going to be equal to 5. Just like we can, like for example, let's say I have even it can be in form of alphabet. Let's say I have, for example, let's say we have 5, 10, 15, 20, 25, 30, 35. If I want to determine my common, if I want to determine my last time, the number of times here, I can just easily count the terms. 1, 2, 3, 4, 5, 6, 7. So meaning here, the number of times here is going to be equal to 7. It depends on the approach of the problem we are solving. So for example, we say int term. So int term here, sometimes they normally, just like it's similar to what we call the last time, but it's not the same. In some cases, like here now, I can just say the last time that we have here is 10, just like how we are expressing the term. So in general, so we normally apply Tn is equal to a plus n minus 1d. You know, we have already explained what each letters represented. We say a simply means the first term, the n here simply means the number of terms, the d that we have here simply means the common what? The common difference. So let's say, how can we express each terms to make our problem more easier? Let's say I want to find like first term, I want to find like second term, third term. You know, if I want to find the first term as usual, you know, first term means when the number of term is 1. Remember, I told you that a simply means the first term. If I apply this formula, are we going to get our first term to be a? So let's check. I want to find the first term here. If I put it here, that means that we have T1, right? You know, our number of terms we are using here is 1, equal to a plus the number of terms we have is 1. Is 1 minus 1d, right? So now I can have T1 is equal to a plus, so 1 minus 1, of course, you are going to have 0d. You know, if I have 1 minus 1, definitely that one is a 0. So now we can have this one to be t1 equal to a plus, so 0 multiple, you know, bracket in mathematics. That's another thing. When we have a bracket in mathematics, it simply means multiplication. For example, if I have 3 bracket of 5, what does that mean? It means we have to multiply 3 by 5, that is 3 multiplied by 5, and that one is going to give us 15. So here, when I have a 0 bracket of d, meaning I should multiply 0 by d. So 0 times d here, and we have a 0, then a plus 0, of course, we are going to have a. So let's say I want to find for the second term. So because I want to make it easier so that you can play with any terms, even if they ask you to identify maybe 20th term or 19th terms or 50 terms or 1000 times, just know how to apply the formula. Let's say I want to look for second term. For second term, what does that mean? Meaning when the number of terms is 2. So once I know my general terms of an AP, I can just apply the formula. Meaning here, the number of terms is 2. That means that we have T2 is equal to A plus the number of times I have here is 2 minus 1, then common difference. So here we have T2 equal to A plus 2 minus 1, of course, we are going to have 1D. You know, I told you that in mathematics, brackets simply means multiplications. So here I can have T2 to be A plus 1 times D. We are going to have 1D. If you notice something, you can see the term is reducing by 1, 1. So let's say I want to find the fourth term, for example, or let's say the third term, so that we don't rush it. Let's say I want to find the third term, meaning when the number of terms is 3. So now I can just apply the formula. It's Tn equal to A plus n minus 1D. Then the number of times that we have here is 3. That's going to be T3 is equal to A plus 3 minus 1D. So that is T3 equal to A plus, so 3 minus 1, of course, we are going to have 2D. So here we have T3 equal to A plus 2D, meaning the time you can see, logically, the time is reducing by 1, 1. So can you guess if I said 10th term? Yeah, exactly. So that means if I want to find the 10 terms, it's going to be A plus 9D. So very good. So now, okay, what if I said 100 terms? How can we write the 100 terms? Yes, exactly. So 100 terms, that's going to be A plus 99D. So if you get perplexed, let's quickly check that. I want to check for 100 times. Why is it A plus 99D? You know, for the 100 times, meaning when the number of times is 100, right? So if I apply the formula, Tn is equal to A plus n minus 1D, then the number of times we have is 100. That's T100 is equal to A plus 100 minus 1D. So here we have T100 is equal to A plus 100 minus 1. We are going to have 99D. So it depends on the approach. You can see that it's very simple. Okay, what if I ask you to find 20th term? How can we write the 20th term? Yeah, so 20 terms, that's very nice. So 20 term is going to be A plus 19D. Just like logically, it's reducing by 1, 1. So if you go back to our material, you see how we make the derivation of this Tn equal to A plus n minus 1D. So let's solve some problems using this formula. We can solve any questions related to the AP using these general terms of an AP. Let's solve some problem. So you can see how we can make use of the formula. They said, example 1, given that 2, 4, 6, 8 are in AP, find, let's say Roman, we go 1, 6 term. 6 term. Roman, we go 2, let's say I want to find 10th term. Let's take a look at this simple problem. They said, given that 2, 4, 6, 8, sorry about that, 2, 4, 6, 8 are in AP, and we asked to find the 6th term at the same time the 10th term. So the first thing for us to consider is for us to find the first term as well, the common difference, and I'll show you how to find the first term and how to find the common difference. So from here, I can easily find my first term as well. I can find my common difference. Now here, let's see the solution. It's very simple and straightforward. What we have is 2, 4, 6, and 8. So here, I can find my first term here. What's going to be my first term here? My A, the first, I told you the first terms, the first given numbers from the sequence. So what we have here is 2. That means our A is equal to 2. I hope you are following, right? Yeah, nice. So now I want to find the common difference. Common difference, I told you that it can be between any terms. You can find it between the first term and the second term, or the third term and the second term. So find is if it's an AP, they must have the same difference. So here, I want to find this one. So if you look at this, if I check this, that's a 4. I can take it like this. That is a second term minus first term, right? Or I can even say third term minus second term. So no matter how the equation comes, just follow the same process. So here I can have D to be. So the second term that we have here is 4 minus the first term we have here is a 2. So 4 minus 2, of course, we are going to have 2. And if you apply this one to third term minus second term, you can see 6 minus 4, we are still going to have 2. So now that means our common difference now is 2, right? Now we are asked to find sixth term, meaning when the number of terms is 6. Recall I told you, okay, how can we write the sixth term? So I told you earlier. Yeah, exactly. That's going to be A plus 5D, isn't it? So I will still show it so that you don't get perplexed. You will be following what we are doing here. So now, what's the general formula? We have Tn equal to A plus n minus 1D. So I'm looking for the sixth term. When the number of terms is 6, is T6 is equal to, now, our first term from the problem is given as 2. That is 2 plus the number of times we have is 6. That is 6 minus 1. So the common difference that we have is 2. We have 2 here, meaning we have T6 is equal to 2 plus 6 minus 1. Of course, we are going to have 5 of 2. I told you earlier, when we have a bracket simply means multiplication. To multiply what we have inside the bracket with the one we have outside. So meaning here we have T6 is equal to 2 plus 5 times 2, we are going to have 10. So 2 plus 10, of course, we are going to have 12. If literally, you can just use logically, you can use this one sharp. If at all that you come across a problem from objective text to save your time. Since you know that T6 is the same thing as A plus 5D, plug in the two values. A is 2 plus 5. The D is 2 also as well. Then we have 2 plus 5 times 2, and we have 10. 2 plus 10, and we have 12. We can see that we have the same result. So now, the second question, they say we should find the 10th term. How can we write the 10th term in that general? How can we write the 10 terms? Exactly. So 10th term is A plus 90. But let's follow it the same way we're supposed to do that. So second question, I was asked to find the 10th term, meaning when the number of terms is 10. So if I go to the formula, it's Tn is equal to A plus n minus 1D. So by using the values, by using the formulas, by using the data that we have for what we are given here, that means that we have T10 equal to, our first term is 2. So that means that we have 2 plus the number of terms that we have is 6. That we have 6 minus 1. The common difference that we have is 2 as well. We have 2. That means that we have T10 equal to 2 plus, now 6 minus 1. That we're going to have for 6 minus 1. Exactly. So 6 minus 1, we have 5 and 2. Then we have T10 equal to 2 plus, I told you bracket simply means multiplication. So 5 times 2, that means we are going to have 10. 2 plus 10, that's going to give us 12. So we are trying to find the sixth term. Sorry about that. So now we are looking for the sixth term here. So but now we are trying to find the 10th term. Sorry about that. If I put the value here, the number of term is 10, right? So meaning when the number of term is 10. So now if I use the formula, that means that we have T10 equal to, my first term is 2, and we have 2 plus the number of term we have is 10. 10 minus 1. Common difference remains as 2. So that means that we have T10 equal to 2 plus 10 minus 1. Of course, we are going to have 9 of 2. So meaning we have T10 is equal to 2 plus 9 times 2, and we have 18. So 2 plus 18, then we are going to have 20. So meaning the sixth term is 12, the 10th term is 20. So we can see how we can make use of the formula. So in some problem, we can have a question that can come in form of a word problem. We can have a word problem questions. Instead of giving it like this form, they can make it in the form of word problem to make it more interesting. So let's take a look at that.